Hello, my name is Amirah Azmi. My matrix number is 210870, and today I will be discussing my mini project, which is the projectile motion of a shot put. So what is a shot put basically? It is a traditional track and field throw event, and the winner is based on the distance that is achieved when someone throws the weighted metal ball, which is called a shot. And it is considered to be a projectile motion because the shot put is projected into the air and it is subjected to gravity. And the three factors that usually affects the results are initial angle of release, the initial velocity of release, and also the height of release. Okay, so my problem description is, what effects does the angle of release have on the horizontal distance of the shot put? And is the ideal angle of release applicable for this throw event? So we will be discussing about that. So for the design assumptions, the assumptions that I've made is that it will travel, or the initial velocity will be constant. The second assumption is that the height will be also constant, which is 2 meters from the ground. And it is subjected to gravitational acceleration, obviously, and the air resistance is neglected. The fourth assumption is that the Earth's gravitational field does not differ with the altitude. And lastly, the parameters are based on the men's category for the sport event. So the design of the shot put is quite simple. It is basically a rounded ball of metal. So the mass that is put for a men's category is 7.26 kilograms. And the diameter is usually around 120 millimeters. And the material is either brass or solid iron. And it can be any type of metal as long as it's not softer than brass. And it must be spherical in shape and has to have a smooth surface. So the calculations I've used are based on or derives from the kinematics equation of motion. As you can see here, this is one of the equation that it has. And from this equation, I had key in some of the parameters I've decided to use that is listed in my report. And finally, we will have this equation that will help us calculate the time of release. No, the time that the ball will travel, as you can see on the FBD. And when we have the time of travel that the shot put will experience before hitting the ground, we can finally use the equation here. That is basically to calculate the horizontal distance that it travels. So this is the graphs that I've attained. I've used Python to illustrate this. So the first graph is basically the time of travel of projectile versus the initial angle of release. As you can see, it is rising quite steadily. And the second graph is the horizontal distance traveled by the shot versus the initial angle of release. As you can see, there is here it reaches the maximum height, the maximum distance. However, on the last one, which is, I think the angle is 48, if I remember, it kind of drops a bit, but not much. And the simulation of the projectile motion I've used is by this Colorado University. Here is one of the examples that I've created using this simulation. So as a conclusion, this throw event has evolved with the calculations in dynamics. And the various equations, such as the kinematic equation of motion, is now being utilized in this century into just basically everything that you would possibly have questions for. And as a conclusion, the assumed optical angle of release actually differs according to the object undergoing the motion. So what is assumed to be the ideal angle of release is not always the same for every object. And also that the mass does not have an effect in projectile motion. And this is basically seeable because in the equation, there is no mass involved. Oh, I think I've made. This is not the conclusion, but it is actually a reflection. So I've utilized Katya and also Python and the simulations I found on the internet. And at the end of this project, I've recognized and realized how many everyday activities that people do daily actually revolves in some way with dynamics. And I have also acquired knowledge about short put events. And in the end of this project, I would have preferred that my discussion can be applicable outside of the lab. But yeah, it's not applicable because the initial velocity will differ in real life and the height of athletes will differ accordingly to the athletic build of a person. So I think that is the end of my presentation. Thank you for listening and watching this video.